the solution to the practice problems on rate of change. When we want to describe how fast we're moving or the rate, we really want to look at it in two things. Is it slow or fast? And is it moving away or toward? In other words, when it's moving away, it's positive. When it's moving toward, it's negative. When it's fast, it's steep. And when it's slow, it's not as steep. It's kind of the shallow graph. So let's go ahead and take a look at a situation here where we have distance on the y and time on the x. So segment A. When I look at segment A, my distance is staying at 2 as time moves on. The only way my distance stays static is if I don't move. So segment A, I'm standing still. And so I'm not moving any which direction. If I look at segment B is decreasing. It's going downward. It's going back to the origin. It's headed down this direction. When I say origin, I just mean back down to 0. And it's decreasing, so it is going toward. So if I was modeling this, I would be moving back toward, and it looks like it's somewhat fast. How do I know it's somewhat fast? I'm just looking at the steepness of a line. In the second situation, we have 3 segments. Segment A. So if I look at segment A, I am headed upward and pretty shallow, so I must be moving slow. So if I'm heading upward, I'm not really moving up, I'm moving away. It looks like it's upward, but if you look at your distance is changing. It's getting further away, and my slope of that line is fairly shallow, so I must be moving slow. My rate of change is slow. Segment B in the middle. Segment B is straight across, so that's where I'm standing still. And segment C is, again, I'm moving away because I'm moving up or positive. My distance is increasing, so it is increasing. And it looks fairly steep, so I must be moving at a fairly fast rate.